As always, please pause the video and try the question before moving on. It's probably a good idea before beginning this question to make a list of the known values that were given. And we can start with DVDT. The question states that gravel is being dumped at a rate of 30 feet cubed per minute. Now the key word there is a rate. And anytime we have a rate, we're going to have a quantity divided by a certain time interval. Now the quantity here is feet cubed, and we're supposed to know, and hopefully we do, that feet cubed represents a measurement of volume, and that minute, of course, is a time measurement. So what that means when we have feet cubed or volume divided by minute or time, we have volume divided by time. That corresponds to DVDT. The question also states that the pile of gravel is 10 feet high. Now after listing the known values, what we can do next is look at the question itself. The question says how fast, note that that's a rate, how fast is the height of the pile increasing? How fast is the height of the pile increasing? Well, because it's a rate, we know that it's going to have a dt in the bottom. And because it's asking about how fast is the height changing, we know that the top will be dh. So the question is asking us for DHDT. Now, what that means is we're going to have to figure out a formula that connects height with volume, since those are the only two values that are given to us. Well, we know that because this object is a cone, that there's a certain formula that applies to it. So let's look at the formula for the volume of a cone. Now what's nice about this formula is that it relates the volume to the height, which is exactly the kind of equation that we needed. The only problem with it is that the equation also contains a radius, and we were not told anything about the radius, so that becomes a bit of a problem. However, we can resolve that problem if we look at the picture that was provided to us in the question. We can mark this distance right here as being the height. The question states, and even shows in the diagram, that this diameter, this distance across the circle, is also h. It's the same value as the height. Well, wouldn't that mean that this distance right here would be half of the height, or h divided by 2? Well, if you look carefully, that distance right there, that's simply the radius of the circle that forms the bottom part of the cone. So, in other words, the radius of that circular shape on the bottom of the cone is equal to h divided by 2. And since the radius is equal to h divided by 2, we can plug h divided by 2 into the radius. Now what's nice about the formula is that it's expressed in terms of a single variable, and that variable would be h, the height. Why don't we simplify this a little bit by squaring the h as well as the 2. If it helps, we can put 1's underneath the quantities that don't look like fractions. We're going to multiply all the tops of these fractions. Now h squared times h to the first will be h cubed, of course, so the top will become pi h cubed. And then the bottom we have 3 times 1 times 4 times 1, which becomes 12. So we have the formula v equals pi h cubed divided by 12. After establishing and simplifying the formula, our next step is to take the derivative of both sides with respect to time. For volume, that's going to be easy because the derivative of volume with respect to time is just dV/dt. The right side isn't terribly difficult either. We're just going to use a power rule where we pull the exponents down in front to give us 3 pi h divided by 12. We have to subtract 1 from the exponent, so it becomes h squared. But because this is a related rates problem, we also have to multiply by the DHDT. Now we can reduce this fraction. We basically have 3 over 12. If we divide the top by 3 and the bottom by 3, that 3 will cancel, and this will become a 4. And now really, at this point, it's just a matter of plugging in known values. Why don't we clean up the workspace first? Now recall that dV/dt was equal to 30 feet cubed per minute, and the height of the gravel pile was 10 feet, and DHDT is our unknown. Why don't we square the 10 and then divide by 4? And then we can divide both sides of the equation by pi times 25 feet squared. That way it cancels out on the right side of the equation. And here we have our value. This can be simplified a little bit. We have feet squared on the bottom and feet cubed on the top. So we can cancel out 2 of the feet on the bottom and 2 of them on the top. That's going to leave us with just 1 foot left over. So we're going to end up with feet per minute as our unit. And then 30 divided by 25, that's just basically reducing a fraction, right? If we divide both sides by 5, we'll have 30 divided by 5, which is 6, and 25 divided by 5, which is 5. And then we do have a pi on the bottom. So cleaning this up, we would have the final answer 6 over 5 pi, and then feet per minute. Thanks very much for watching this video. If you like it, please subscribe and stay tuned for more solutions to calculus, physics, chemistry, and other types of homework questions.